Alright, so that now let's discuss about the famous topic, which is about area. Alright, so before we solve anything, we will only cover three shapes right here. We're going to cover rectangle, triangle, and trapezium. Alright, let's start with the definition. So area means the amount of surface in a certain region. So for example, there is actually a boundary you're talking about. So for example, this is our region or the figure that we want to compute the area. So we're only talking about what's the amount in this region. All right, so it's only a 2D shaped, and what's the amount in that region. Okay, so the area of a closed figure is the number of square units it encloses. So simply saying, so that it's not just shading a certain area, we also say that the definition of the area is actually how many square units. So we mean like there's like a certain unit that we have in common, and we want to check how many square units are there in that certain figure. So right here, for example, we say each of these square units are equal, right? They don't look equal, we will just assume that they are equal. So therefore, we're talking about the area of this figure right here. So if we will count how many square units do we have here, therefore we have 1, 2, 3, 4, 5, 6, and there's 4 lines, so there's 24 square units. We did not say what unit it is. Alright, so that's why whenever there's no unit written in a certain figure, we just claim the square units as our unit. Okay, in the metric system, the units we use for the measurement of the area are related to the units we use for the length. That simply means, for example, if you have a square, alright, so we say this is a square. So they are all equal size, and this is 2 meters, right? When you find the area of the square is actually side times side. Alright, so side times side. So therefore, you just multiply 2 meters times 2 meters. So you'd have 4 square meters. So see the relationship? The length that we have is meters, and the area is square meters. Right? So you just add the exponent to whatever unit you have. Right? Let's start solving. So the rectangle, what's the formula for the rectangle? So the area of the rectangle, area of the rectangle is actually computed with the formula length times width. So for example, we have a certain rectangle right here. Alright, so there's a certain rectangle. Okay. Alright, let me redraw that. So we have a rectangle. And this is 15 centimeters, and this is 3 centimeters. We want to find what's the area of this. So very simple. We just multiply them. So that would be 15 times 3. Alright, so 15 times 3 would give us the answer of 45. And you shouldn't end that way. You should also remember that you have the units cm, and never forget the 2. Okay? Therefore, that's the area of our figure. Remember, as what I said earlier, square earlier, I showed what's the formula of the square. Okay? The formula for the area of a square is actually side times side. As you remember from the definition of quadrilateral, square is classified to be a rectangle. Okay? So therefore, this formula that the square has, square is a special type of a rectangle. Alright, so the formula for the area of the square is actually taken from the formula of the rectangle. So area is equal to side times side, which is like its length and width are the same. Alright, so therefore, if for example this is 5 meters, and this is also if one side is 5 meters and this is a square, all sides are 5 meters. So what you do, therefore the area of the square would be 5 times 5, or 5 squared, and this is 25 square meters. Never ever forget the square or the exponent. Alright, so that's for rectangle. Now let's go to the next shape. So we have here in the next figure, we are going to talk about triangles. Alright, so triangles. What about triangles? So triangles, we have the formula. The formula actually for triangles is 1/2 and then multiplied to the product of base times height. The easiest way to rewrite the formula would be the area of the triangle is equal to base times height divided by 2. Right? This has the same value. So for example, this is applicable to all types of triangle, whether your triangle is a right triangle, right? Or your triangle, you say that the triangle that you have is like this. This is like an isosceles triangle. Two sides are equal. Alright? Or whenever it's like that. This is like an obtuse triangle, right? Okay, so any type of triangle, you can actually... Oh no, this is... let me erase that. Doesn't look good. Okay? So, whenever you have a triangle, first is you identify what's the base and the height. So, the height is the bottom part. The bottom part is the base. Alright, so that's the bottom part, base. And then, so to see that? So, that's a height and the base is the bottom part. This is the one. Well, this one is our height. Okay, the height. And this is the base. Okay, so you're trying to make two parallel lines. And this is our... This is the height. And the base, for this part here, you won't count this missing part. So you're just taking the base as this one. The base of your triangle. Right, so let's continue. Therefore, here, so if you want to check the value, so you should say, you will say, like, for example, I have here a certain right triangle. I want to solve the area of the triangle. Alright, so this is the triangle. And let's say the height is 10 meters. And then the base is 7 meters. Right, so what we do, we just simply substitute the formula. So therefore, the area is equal to the base. So 7 times the height, 10 divided by 2. Right, so 7 times 10 makes 70, and then divide by 2. Therefore, this is equal to 35. And don't forget the unit area again would have square meters. Right, very clear and easy. Okay, let's continue. Actually, I forgot to write the parallelogram slide, so I will just write it here. So what if we have a parallelogram? So remember the definition of a parallelogram. So when we say parallelogram, two sides are parallel. Okay, so one example to this is our rectangle. A rectangle is a special type of parallelogram. So say this is parallel to each other. Right, so two opposite sides are parallel. Therefore, what we will do, we would... Actually, the formula for the area of a parallelogram is base times height. Right? So it's similar, it's really similar to the formula for area of a rectangle. So let's identify the base. The base is this side here. Okay? This is our base. Alright? And the height, actually you can take the height or you can find the height in two ways. So you can have it this way, the inside part. It's like the perpendicular line there. So this is also the height. Okay, these two are the height. So that's simple. You just simply multiply them, whatever value you have. So for example, we have a certain parallelogram right here. And it says that this is 3. This is, let's say, 7. And then this part right here is let's say 4. Okay, So actually, sometimes students would get confused about the side here and the height. Alright, so remember the height is the perpendicular line from one of the vertices, top vertices. So therefore, when you solve for the area, it would be area is equal to base times height, which is 7, times 4. And you'd get 7 times 4 is 28. Okay, you don't have the unit. So if you don't have the unit, you just simply write square units. Okay, as simple as that. Right, so the last one is trapezium. So when we talk about trapezium, one side is parallel and the other two sides are not. So it could be like this. So that one. Alright, so like that. Okay, so this is a trapezium. So we have one side is parallel. These two sides are parallel. So let's say this is A, B. Okay. This is parallel. A and B. Actually, A is one of the sides of our trapezium. And how do we identify the height? Right, so how do we identify the height? Okay, so how do we identify the height? So what we do is we just put two lines again, as what we did earlier, and make another perpendicular line right here. Okay, so this is our height. Right, so as you can see, if this is like that, therefore this should also be the same, right? So if you're given with this value or this value, they are the same thing. Okay, they're actually equal. So let's try and answer now. What if we have this? So what if we have this height right here? So, this trapezium right here. So there's a trapezium drawn here. Okay, and then we say this is actually 3 centimeters and this is 5 centimeters. And we say that the height is like that. The height is, let's say 7 centimeters. So what we do, we just simply apply the formula. So area is equal to A plus B. Always write the formula first when you're solving, times the height. Therefore, that would be RA is 3 plus 5 all over 2. And that would be times the height, which is 7. So it will be 5 plus 3 is 8 divided by 2 times 7. Alright, so 8 divided by 2 is 4 times 7 would be equal to 28. And don't forget the unit, centimeters square or square centimeters. Alright, so that's all for area.